We've met the generator, the forger, we've met the discriminator, the detective. Now it's time for the main event. How do you train two neural networks that are competing against each other? Welcome to the adversarial game, the engine that makes GANs work. The training loop has two alternating phases. Phase 1, train the discriminator, show it real images from the dataset and fake images from the generator. It learns to tell them apart. Phase 2, train the generator. Feed noise through the generator, pass the fake output to the discriminator, and backpropagate the discriminator's judgment back through the generator. The generator never sees real images directly, it only learns from the discriminator's feedback. These two phases alternate step after step, epoch after epoch. Let's zoom into phase 1. We sample a batch of real images from our training data and label them as one real. Then we sample random noise, pass it through the generator to create fake images and label those as 0, fake. Both batches go through the discriminator, it makes predictions. We compute the binary cross entropy loss. The key detail, we only update the discriminator's weights here. The generator is frozen during this step. We want the discriminator to get better at distinguishing real from fake before we challenge the generator again. Now phase 2, the generator's turn. We sample fresh noise, pass it through the generator to create new fakes. These fakes go into the discriminator, but here is the twist. We label them as 1 as if they were real. Why? Because we want the generator to fool the discriminator. When the discriminator says this is fake but the label says real, the loss is high. That high loss flows backward, but this time only through the generator. The discriminator is frozen in this phase. The generator adjusts its weights to produce images that the discriminator would call real. Let's look at the math behind both phases. The discriminator's loss has two parts. For real images, maximize log d of x, the log probability of correctly identifying real data. For fake images, maximize log of 1 minus d of g of z, correctly rejecting fakes. The generator's loss is the opposite. It wants to minimize log of 1 minus d of g of z, or equivalently, maximize log d of g of z. Together, this forms a minimax game, the famous equation min g max d of the expected values. Two players, one objective function, opposite goals. What does training actually look like over time? In the early epochs, the generator produces pure noise, the discriminator easily rejects everything. After a few hundred steps, shapes start to emerge, blurry, distorted, but recognizable. By the thousands of steps, the images sharpen, details appear, eyes, hair, textures, and eventually the generator produces images that look remarkably real. The discriminator's accuracy drops toward 50%, it genuinely can't tell the difference anymore. Training GANs is notoriously difficult. The biggest enemy is mode collapse. This happens when the generator finds one type of image that fools the discriminator and just keeps producing that over and over. Instead of diverse faces, you get the same face repeated hundreds of times. The generator has collapsed to a single mode of the data distribution. Solutions include mini-batch discriminator, can compare across samples, and careful learning rate scheduling. Some architectures use Wasserstein distance instead of BCE, which provides smoother gradients and helps prevent collapse. Here are battle-tested tips for stable GAN training. 1. Use batch normalization in both G and D, except the output layer of G and the input layer of D. 2. Use Adam optimizer with a low learning rate, 0.0002 works well, and set beta 1 to 0.5. 3. Normalize your real images to -1 to 1, matching the tanh output of the generator. 4. Add label smoothing. Instead of hard ones and zeros, use 0.9 and 0.1. This prevents the discriminator from becoming too confident. And 5. Train the discriminator more than the generator, usually 2 to 5D steps per gauge step. So that's GAN training, an adversarial game where two networks push each other to excellence. In our final video, we'll see the full GAN in action, generating images from scratch step by step. Stay curious.